Students, we know the basics of similar and congruency, and we have heard in our earlier classes that the figure which have the same shape and size are called congruent, and the figures which have the same shape and with the same magnitude, when they are changed, increased or decreased, that type of figures are known as similar figures. So with that concept, we can say that two figures will be similar if they have the same shape but size may be different. Okay, suppose I am drawing a line segment here. This line and this line are similar. If I will say this square is similar to this square, here what is happening? The size of one square is decreasing with the same ratio of the size of other square. So this type of figure is known as similar figure. Okay, we have got some of the examples from our practical life that when we go to the photos of our small passport size photos, it's enlarged in such a way that it looks same, that means similar to our passport size photo, and it's become a wall frame, is not it? So student, suppose we will take one concept. Now look at here. Suppose this is a triangle ABC. If we will take any point outside of this triangle ABC and we will join these points OA, AB and the third point OC. Okay, now what will happen? If we will extend these points such that this OA is equal to AP, suppose here is P, then OB is equal to OQ and OC is equal to OR. Then if we will join P, Q and R, we will again get a same type of similar figure, and the same type of similar figure is the triangle P, Q, R. So this type of figures, here what we will get? We will get that the side AB is suppose a length of side AB. If we will make a ratio with the length of this PQ, we will get a constant value. It will be AB will be half of this PQ, then similarly BC will also be half of this QR, and this AC will also be half of this PR, and like this we will get a ratio of 2. If AB is half of PQ, then we can write down AB, or it is twice of AB, then AB cancel, we will get a ratio of 2. And this ratio, whenever we are enlarging a point outside, if it is greater than 1, we can take it K. Suppose if it is greater than 1, then we can say that the figure is enlarged. If the ratio is less than 1, then we can say that the figure is reduced. Reduction. Apart from this, there is one theorem in our unit of 8 geometry, and the theorem is that a given straight line can be divided internally or externally in a given ratio at one and only one point. So we have a theorem, this one: a given straight line can be divided internally or externally in a given ratio at one and only one point. So let us prove this theorem. Suppose a given straight line is this is AB, where suppose X is a point which divides this line into n parts. We are proving this one for internally division. Now let us understand what is the theorem says. A given line segment divided in a ratio m:n in only one point, that is X. Here AB is divided into two parts, AX and XB, such that AX is equal to M and XB is equal to N. Now how we can write AX by XB will be equal to M is to N. Is not it? Yes. Now if this is possible, then we can say that AX is to AB. What is AB here? AB means M plus N. So we can write down like this: M is to M plus N. Now here we took X as a point. Now suppose we will think that the given line will be divided in the ratio m is to n in many ways. So we will again take a point P on this line. Suppose this is a line and here X was the point, and let us take P a point here. Then again what we will get? Let P be another point on AB. Let P be another point on AB. So such that what we will get, AP is to, or we can write down AP by PB is equal to M is to N. Then we can get that AP by AB is equal to M is to M plus N, because AB is a full part of M plus N. From this one, this is supposed to and this is 3. What we can write down? M is to M plus N, M is to M plus N. That means these parts are same. So we can write down that AX by AB will be equal to AP by AB. Then what we will get? We can cancel this AB and AB. So we are getting AX is equal to AP. If AX is equal to AP, that means X and P are coincide. That means the point X and P are same. So therefore from this what we can conclude, the point X and P are coincide. So therefore the point X and P are same. That means what we can say? We can say is that X is the only point on this straight line which divides AB, which divides AB in M is to N ratio. This is all about the internal division of a line AB. So let us go for the external division of a line AB. Let us take a one external division. Suppose this is a line AB it is divided in such a way that the ratio Ax, this part from this to this it is m, and from this to this it is n. Then what we will get from here to here, it is m minus n part. Yes, it was total m, it was total n, so we are getting m is to n parts. So from here what we can write, Ax by Bx is equal to m is to n. Similarly, like the internal division, what we can say, the points, only one point will be there which divide the line segment into m is to n ratio at one and only one point, and that point is the x. Based on this theorem, number 1, there are some questions on the exercise. So let us move to the exercise. Look at the question number 9 of the exercise 8. What is the question number 9 on the exercise 8? If a straight line 9.6 centimeter in length is divided internally in the ratio 5:7. The first is that a straight line, suppose this is a straight line 9.6 centimeter. Suppose it is A, it is B, and it is of 9.6 centimeter. Is divided internally in the ratio 5:7. Is divided internally in the ratio 5:7. So here we have to find the length of each segment. So we know that any point which divides a line segment in only one part. So therefore we can write down Ax by Xb is equal to 5/7. Let us take Ax is equal to 5k and Xb is equal to 7k. Yes, so we are taking this k, suppose common. From where we got? We got this one from theorem number 1. So the total length of this line segment AB is of 9.6 centimeter. So we can write down like this: Ax plus Xb is equal to AB. And what is Ax? Ax is our 5k and Xb is 7k, which is equal to 9.6. The AB is given. So from here what we will get? K we can get 9.6 divided by 12. If we got the value of this k 9.6 divided by 12, then easily we can find out the Ax. Ax will be our 5 multiplied by k. 5 multiplied by 9.6 divided by 12. 12 8 are 96, that means it is 0.8 and it is 4.0 centimeter. And Bx will be our 7k. Let us see what is 7k. 7 multiplied by 9.6 divided by 12, which is 0.8, so 5.6 centimeter. So we are getting the two line segment Ax and Bx in the ratio in 4 centimeter and 5.6 centimeter. So these are the two line parts of the line segment 9.6 centimeter, where it is divided internally in the ratio 5:7. Now if we will go for the question number 2, we can find that in question number 2 we have to show that the straight line a centimeter. Here a straight line is given. Suppose here a straight line A, D is of given a centimeter. In length is divided at a point in the ratio m:n. Yes, suppose it is divided in the ratio m:n. Internally, then we have to prove that the length of the two line segment will be like MA divided by M plus N centimeter and NA divided by M plus N centimeter internally. So let us see. Here, if it is divided internally, what we will get? Let us see. Suppose it is divided internally, then we can write down AX by XB is equal to M by N. Correct? Then what we can say? We will take this one K, suppose. Then we can say that AX is equal to MK and XB, that is BX is equal to NK. Here AB is our total length, A centimeter. So we can write down now that AX plus XB is equal to A. That means M plus N, this length will be equal to total this length. So AX plus XB, MK plus NK of A unit. So K will be our A by M plus N. So from this we can find that the two parts will be what? AX, that is M multiply A by M plus N, and BX will be our N multiplied by A plus M plus N, and we can write out it is MA M plus N and it is NA M plus N. This is the division of internal. Similarly, we can divide the line segment externally also. Now let us see how we can divide the point externally, and we can prove that when a straight line A centimeter is divided at a point externally in the ratio M is to N, the external division, the length of each segment will be MA by M minus N and NA by M minus N centimeter. So let us take one division externally. Suppose this is a line segment AB. It is divided externally up to this point X, and it is M. From here to here it is M, and from here to here it is N. Then what will be the length of this AB? The length of this AB will be M minus N. So since we have a theorem, a line segment can be divided at a one point in the ratio M is to N, internally or externally, then therefore we can write down AX by BX will be equal to what? M is to N. Then we can write down AX is equal to MK and BX is equal to NK. Suppose we can take is equal to K constant. But what is AB? If we will see AB, what is the length of AB? Now AB is our what? AX minus BX. So AB is our what is the length of this AB? A unit. What is AX minus BX? It is MK minus NK. Here it is given of A unit, which is equal to M minus N. So from here we can find that K is equal to A by M minus N. So what is the length of this line segment AB, or this AX or this BX? We can find this very easily, that AX will be our MK. K means A by M minus N, that is MA by M minus N, and BX will be NK. K means A by M minus N, that is will be NA by M minus N. The same type of question is there in question number 3. So I hope you have understood the question number 2 very well.